Again, real quick, this is Azat. He's going to talk about patterns, and I'm going to
Hello.
let him run away with it.
Can you hear me? This is awesome. I haven't been yet to the conference where they have live music during the breaks, and it's very refreshing to be at this type of conference. It doesn't feel huge like some other conferences, so thank you for having me, and I'll be talking about node patterns from callbacks to observer. So how many of you use Node.js like day-to-day besides just Grunt or Webpack or Gulp? Okay, like 30% of the room. So the first pattern, it's called one true JavaScript exception. And basically it takes and opens your browser at a Stack Overflow, right? So this is a joke, but I went ahead and implemented one true Node.js exception handler. So it opens a browser at a Stack Overflow, and what's good about it, it also will process your asynchronous error as well, because process.nextTick exception. I will catch that. Well, this is also a joke, but why do we need to know better about the Node.js patterns? So first of all, if you want to become like a go-to person in your team, or maybe in your organization, Node.js go-to person. So this is definitely something you want to explore. Another reason, if you're a person who likes to basically geek out on those low-level concepts, on those like under-the-hood mechanisms, so definitely pay attention to this talk, turn off your Slack, your HipChat, your IRC, put yourself on the airplane mode. The slides are available on GitHub, so everything is open source. We'll have open source, right? So if you notice a typo, I'm not great at typing, that's why I have good editors. So there's a GitHub repository, open an issue, submit a pull request. The PDF is there, the Markdown is there, the code is there as well. I have some code examples. Just to introduce myself a little bit more, my name is Azat Mardan. You can find me on the internet, AZAT_CO in most of the places. I write about Node.js, JavaScript, and startups, and now corporations as well, on webuplog.com. That's my blog. I work currently at Capital One. It's been 1 year since I joined Capital One. I absolutely love it. It's a great place to be. I'm a technology fellow there. Before that, I worked at small companies. I worked at startups. I worked at federal agencies. And also, I teach Node.js and React under the nodeprogram.com kind of a brand. You might have seen some of my books. I've published and wrote 12 books. The most popular one are Practical Node.js and Pro Express. The new one is React Quickly. Don't tell my publisher I told you this, but probably you don't need to buy them. If you just Google the name of the book, you will find it online somewhere for free. Okay, so let's start with Node.js. So why Node.js is good, why we love Node.js? So it has this non-blocking I/O, which is really fast. Basically, it's for most of the times it's JavaScript. Familiar, good old JavaScript, but it's not absolutely equals to JavaScript. It's not triple equals to JavaScript, so there are some differences, right? And JavaScript could be sometimes hard because we have to think asynchronously. And human brains, I think they just didn't evolve to think in an asynchronous way in terms of, oh, this process will be run in parallel, that process will run concurrently. We like to think in more synchronous ways, right? So JavaScript can be hard. So let's start with the first problem. So in an asynchronous world, in an asynchronous program, how do we schedule something in the future, right? Because we don't want to wait for that process. It's not a synchronous process. So, as you know, some of you know, in JavaScript functions, they're first-class citizens, right? So why don't we just define a function? It will be a value of some variable. We can pass that variable just as any other value. That's similar to we passing strings or numbers, right? So that's your callback. Callback is nothing more than just a function. So you all know what this will do. It's a setTimeout. It will schedule something in the future. And then we have certain conventions. So conventions, they're not enforceable by Node.js platform, but most of the modules, especially core modules, they follow this convention. And if you're publishing your own module, you want to follow these conventions because otherwise almost no one will contribute to that if you come up with your own convention, right? So the first convention is that the callback is the last argument, right? So the callback is the last argument, then you can have certain inputs like a file name, for example. This is FS, file system module. And the second convention is that we have error as the first argument when the callback is returned. So when that module under the hood, it invokes the callback, error is the first argument. And then the data that is coming would be second. We can have more than 2 arguments, obviously. So those are 2 conventions. Again, they're not enforceable, so you can come up with your own convention, but it's highly, highly discouraged. It's not recommended. And the naming doesn't matter, so error doesn't have to be named error. You can name it foobar, you can name something else, you can name it E or ERR, but what matters is the order. So that's how the module will know what to pass, basically. And the only way, unfortunately, the only way, if you're using plain JavaScript, you're coming from Java, which is a strongly typed language, right? The Java will basically have interface that tells you, oh, this is an object of a type error, so you need to provide that object. So in JavaScript, there is no way to know unless you read the documentation or you read the source code, right? So you need to know, or you look at examples like this, or you read a book, right? So you need to know that the first argument is an error. Okay, so let's move on. Another problem that we have in how to ensure the right sequence, right? So let me give you an example. We want to update some data, but before we can update that data, we need to first get the existing data, and even before that, we need to authorize our client, right? So these 3 HTTP requests, they need to be done in a certain sequence. We cannot just go and try to update the data. So we can easily nest the callbacks. So this is called nested approach, right? The one tricky place here is that with each callback, we need to handle our errors. So remember that error, the first argument. So each time we need to check for that. We cannot just throw error. If you throw error, the whole process will crash, basically. We cannot do that. It's not Java. In Java, we can throw errors. So this could lead to callback hell. Some of you might seen complex code like this. It could be really complex, especially if you have more logics, more functions inside of somewhere in the middle of those callbacks. There is even a website, callbackhell.com. So one of the solutions would be to abstract the function names. So for example, in the previous example, I used anonymous functions, functions without names. In this example, I'm naming the functions. It's also called hoisting the functions. It has an added benefit of the names will show up in your stack trace when you have an error, so you will know exactly where that error happens. If you use anonymous functions, you won't get the name of the function, obviously. And as you can see, the indentation reduced dramatically, right? So it's a little bit better to read. Let's take it one step further and abstract the functions in the modules. So by abstraction, I just mean copy-paste. So we create a new file, copy-paste the code, and we import that file in our main file, right? So most of you do it already, modularize your code. Added benefit is that more people can work on those files because now you have separate files instead of having a monolithic one file, right? It's easier to merge your Git pull requests. Now, how do we actually properly modularize, right? So in browser JavaScript, we don't have modules natively. In Node.js, they solved this problem for us. We have modules, right? And in order to export some functionality, we need to call this magical object. It's called module.exports. So basically, it's available to us magically by the platform anywhere, and we can assign pretty much anything. So in this case, I'm assigning an object. And there are 3 main patterns that we can use. Module.exports equals, module.exports.name equals, or exports.name equals. So let's take a look at the first approach. I usually see this approach used, and I use it myself when I have just one big piece of functionality or one big object in a file, right? Because if you think about it, if you have multiple exports and you would use module.exports, the last one will overwrite all the previous ones, right? So really, if you're using multiple module.exports in one file, that's not a good approach. So if you have one piece of functionality in one file, use module.exports equal. In some cases, when you have multiple, let's say it's a utility file and it has 10 or 15 utility functions. They are different in terms of what they're doing, but they're similar in the category. So in this case, it might be better to use module.exports.name or exports.name. Module.exports.name and exports.name, they're exactly similar, only you have to type less. You don't type module. Now beware, you cannot use exports.equals. It's not going to crash, but basically it's not going to export anything, because what you're doing, you're just creating a global variable. Without the var, the global, the exports will become a global variable, and it's not going to actually export anything from that module. So another problem is like, okay, so I have this object. It's going to work if I have some static data like locales or maybe environmental information, some translation maybe. But what if I want to perform some code, some logic before I actually export anything, right? So in this case, it's very easy. We're just exporting a function. By exporting a function, we can actually execute some code, and we can also take some data, for example, options in this case, and we can interpret that data, massage the output a little bit. So we have more power, basically, right? It's a more flexible approach. We can do more things with exporting functions. Again, we don't want to use exports equals function, because that would not do anything for us. An interesting mechanism that Node is using, it's caching modules. And if you put the code outside of exports, it's totally fine, you can do that, but that code will be executed just once when you require that module. And the code inside of the exports, that would not be executed at the require. It would be executed only when you actually invoke this function. But it could be executed many times, while code A will be executed just once. So let me show you a quick demo. So this is import-main file. Let me make it larger. So first, I'm importing my module, which is just a file. It's not a package. It's not an NPM package. And I'm saving the reference in the F variable, right? And then I am importing the same module again. So let's go and open this module. So I have code A, which is outside of module.exports, and then I have code B, which is inside, which is just a function. And let me go to the terminal. So I'm using a Sublime plugin that's just a terminal inside of my atom. And all I see is code A. So what is actually happening here, I never called the function f. While I'm importing the module twice, code A executed just once, because for the second time, Node didn't actually pull that module. It's used the cached version. And then I never called the f. So if I want to call f, I can do this, or I can do this. So now I would expect to see code A one time, and then code B twice. Okay? You all follow me? So let's go to the terminal and test my hypothesis. Okay, so I see code A, code B, code B. Okay? Clear for everyone? So there are still valid reasons to put code outside of exports. Just know that it's going to be executed and when it's going to be executed. Okay? This leads us to another pattern, which is called importing a folder or a plugin pattern. So in this case, routes, it's a folder. It's not a file. So I'm using // That's how Node.js knows that it's not a package. It's an actual file or a folder. And then this is my file. Basically, inside of that folder, I create a file index.js. So it's a certain convention that Node platform follows. So all I need to do is create a folder, then create a file index.js inside of that folder. And then most of the times, all I'm doing in that file, it's basically like an abstraction layer. It allows me to import, and then export other files. So when this might be useful. For example, let's say I have 50 different routes. I have different files, 50 files, and I'm using them in 10 different places in my application. So now, out of a sudden, I need to import 50 different files from 10 different places, right? So this pattern will allow you to import just one folder from all across your application. And if I need to make changes, for example, I need to add a new route or remove a new route, I need to do that just in one place in my index.js file. I don't need to go and look for other places. So basically, it's another level of abstraction, just like a middle tier. You insert that middle tier. You create a plugin. And in fact, this is a very common pattern. NPM is using it. So when you're installing Express, Express will go into your node_modules folder. So if you go into node_modules/express, you would see index.js. So index.js acts as a single entry file where all of the Express.js functionality will be available to you. So now let's talk about singletons. Singletons, another one of those powerful patterns. It's useful when you need to have a state and share that state across your entire application. So maybe you want to save some variable or some object and make it accessible through your entire application. Maybe some configurations. And most of the times, it's not persistent. It's just in-memory store. We can leverage that feature. Remember that modules are cast, right? So we can leverage that feature and implement a singleton pattern using modules. So I've created variable A just to show you. It's not part of the singleton class or an object, but I just created it to show you that it's a private, sort of. We're not exporting it. And then B, that would be part of our singleton. So this is my main program. I'm importing my singleton class, which is module. And then I don't have access to A because I didn't export it, right? So it's undefined. It's totally fine. And then B, it's going to be 2. That's my initial value, right? What's interesting, I can increment that. So m.b++ would increment the value of B. So it will be 3. And then I'm importing another file. Let's say it's part of my application. And I want to access that shared state. I want to access that singleton from my other file, right? I can totally do that by just importing the same module, and my variable, the B, it will have the latest value. It will have 3 instead of 2, right? So this is very, very cool. I think we can skip the demo, but the code is on the GitHub if you want to play with it. One problem with how caching in Node works is that Node is using file names. So if I'm using capital case, or some other developer joins the team and they don't know that we always use lowercase for modules, right, or for file names, this will result in a different caching. So the same module will be cached differently, right? So we will lose that shared state. We cannot use it for singleton anymore. Also, paths, especially on different platforms, might act differently, right? So it's not very predictable. So what we can use? We can use global. So global is one of those magic objects. It's available across all the scripts. And we can just attach a variable. And we can use capital case as well. It's just an alias. Take a look at this example. I just wanted to make my console log a little bit more beautiful, and I decided to add some color to it. So what I did, I created this module. It's like a file, and then all I'm doing I'm just importing this file. I'm not even invoking anything. I'm not even saving it into reference because my file will just go ahead and overwrite the global console.log. That's what it will do. So first I'm saving the original console.log, then I'm overwriting it by adding some colors, right? It's very, very powerful. This is a little bit more advanced example. I decided that for console.info and console.error, I want to have different colors. And I also decided I don't want to type that much. So instead of typing console.log, I just want to type log. So I'm creating global.log, and I'm assigning it to console.log. So basically, it's an alias, it's a shortcut. Again, I don't need to invoke anything. All I'm doing is just importing this file, and magically I have these global variables across my entire application, right? Very, very cool. But could be damaging if you don't really know if you're overwriting something, right? So use it sparingly. And this is exactly how the browser JavaScript module works, like quote-unquote modules, right? So when you import a file, like the only way to share that functionality is to use window, which is a global object, right? So be careful when using it. Okay, so now let's talk a little bit how we organize the code when we use module.exports. So most of the times we want to use something like a class, right? ES6 classes or pseudo-classical inheritance, which uses new keywords. You need to use prototype. In my opinion, it's more complicated than it needs to be, right? And then ES6 classes, they lack, you cannot define properties. You need to define properties in the constructor, right? And if you click on this link, it will take you to this article by experienced programmer and author, and he explains why he doesn't like ES6 classes, right? So I'm not bashing on ES6 classes. I'm just telling you it's not like a magical pill that's going to solve all our problems, right? So, and if you forgot or don't know what prototypes means, it's basically objects inherit from other objects. They don't inherit from classes, right? This is what I personally like, and I see it in a lot of modules. It totally makes sense. It has very minimal code. It's easy to read, easy to understand, especially for beginners. So it's a good old function factory. So we have a function and we return an object. That's all it's doing, right? We can accept some arguments, and then we can tweak our resulting objects based on those arguments. So we have our initializer/constructor code in the body of the function, and then we can do everything inside. If we need to extend some object that created via the pseudo-classical or prototypal inheritance, there is this method in the core Node.js. There is a library, it's called utils, so we can use inherit from the utils. So another problem is how do we enhance the functionality? So now we have a class or an object from a class, right? But let's say we want to enhance, we want to extend, we want to add some functionality, or we want to a little bit augment that class, that object on the fly, so to say. We can use a decorator pattern, and this is just one of the ways. There are many ways to implement it. This is a functional way. So let's say, and if it's too small, go ahead and download the slides and just open the Markdown online. So I'm having a user model. It's just a regular user model. It doesn't have features like add or remove user, right? And then I have admin model, which takes the user model and adds extra methods. It's all done in functional ways. So admin model takes user model, and then as a result, we have this enhanced admin model that has add user, delete users. So so the result would be 30 because the limit is incremented by 20. With prototypical inheritance, you can also use decorators. This is another example. So basically, I'm taking the global object as a global object. And I'm extending its functionality by just adding a new method to pretty.json. So you've heard about JSON to stringify, right? But usually it will just ignore all the spaces. It will just jumble up all together. That's not very developer friendly. It's not easy to read. So I like to use null and 2. So 2 means it's a 2-space indentation. So it would nicely format my JSON. And what I'm doing is just creating a new method and saving it in a prototype of that global. So now, out of a sudden, every new object that I create will have this two-printed JSON. String, object, literal object doesn't matter. So because they all use object as a prototype, they will all have this method. So it's very, very powerful. In fact, this nice library, should.js, it uses this pattern. So when you require should, you don't even need to store it as a reference. You just require that module. And all out of a sudden, you have this property that should on all of your objects. That's how you perform testing. It's a BDD, behavioral-driven development. And the difference between using the prototypes and the functional, when you use objects created by functions, each of them will have their own copy of a method. When we're using prototypes, when we add something to the prototype, the instances will also get that change. So it could be a feature or a bug, depending on how you use it. Okay, so we all know that Node is not blocking. That's amazing, but we can still write code that's blocking our process, right? And it's a single-threaded. It can bite us in the tail. So typically, we'll write IO-bound systems in Node.js, but sometimes we have to perform some CPU-bound processes, some heavy lifting, right? So what we can do in this case, we can offload some of that work for the next cycle. How many of you seen code like this? Okay, just 2 or 3 people. It kind of looks ridiculous, right? So set timeout and 0. Why in the hell would you schedule something just 1 millisecond? It doesn't make sense, right? Well, in fact, it makes a lot of sense because the way set timeout works, and if you remember, we had that event loop, right? Which is always spinning, always looking for something to execute. So set timeout will actually schedule stuff on the next cycle. So you can offload some of your heavy CPU process on the next cycle and let the event loop do something else and then come back to your heavy process, right? SetImmediate works very similar to setTimeout. So that's why I have them on the same slide. So first we will see step 0, then we will see step 0.5, and only then we would see timeout, which is inside of this. So it will skip setImmediate, it will skip setTimeout, it will print step 0, step 5, and then it will go on the next cycle, execute timeout, and then execute step 1, step 2. So setImmediate inside of setImmediate will be scheduled on yet another cycle, right? So we have 3 cycles here. First cycle is 0 and 0.5. Second is timeout, step 1, step 2, and third is step 3, step 4, right? So if you're doing hashing of a password, if you do something that takes a lot of CPU, you can just have timers. So let's say every 100 milliseconds, schedule it on the next, come back it on the next cycle, come back to it to the next cycle. So you still can process other requests, right? There is also the thing, it's called NextTick. It works a little bit differently. Instead of putting it on the next cycle, it's putting it on the same cycle, but at the very last step. So as a result, we will have step 0, step 1.5, which is just a normal execution flow. And then we would have step 1, step 2, which is process.nextTick. And then we would have step 3 and step 4, which is inside of the NextTick. So it's the second level of NextTick. And only then we would see it set timeout. So this is, in fact, just 2 cycles of event loop, because process ticks will stay on the same cycle, right? And there's some confusion. In fact, maybe they should have named it differently, right? Because next tick, it's actually this tick, and setImmediate is the next tick. It's not immediate, right? So this is one of those inconsistencies. Okay, so how do we ensure continuity? For example, remember that HTTP request, we need to continue execution after some piece of logic is done its work. there is this thing, it's called middleware pattern. It's very popular in Node.js, and it has, again, it has a little bit of confusion, so let me demystify it once and for all for you. Middleware is just a function. That's it. There's no magic to it. Middleware is just a function. It takes some arguments and it has a callback. Usually we name it next, but again, naming is not important. And once we're done with this piece of logic, with this function, we just call the callback. We invoke the callback, we invoke the next. And that's it. It goes to the next middleware, it goes to the next middleware, etc. Now, just the functions by itself, by themselves, the middleware by themselves, it's not going to work. We need a middleware manager. So, and usually middleware manager is implemented by someone else. We just use a library or a framework. For example, Express.js. Express.js has the middleware manager, so all we need to do is provide the middleware. And the reason why we do it, because we want to abstract some logic. So instead of having one monolithic request handler, as we would have in the core HTTP module, we would break down that functionality in many middleware steps, and then we can publish it as a separate module, we can import a different module, right? So it's better code organization. This is how we define middleware in Express.js. Again, Express provides the manager for us. So all we need to do is just provide the functions. So going back to callbacks. They're not solving all the problems. I was at the great workshop on promises 2 days ago by Marty. So callbacks are usually at the end of the function, right? We call them at the very last moment. There is no way to have like multiple callbacks, right? And the solution, it's not always promises. The solution is observers or EventEmitter. So let me give you an example. I have a module which is performing some task like sending emails, and I name it job. And then I have my main program, my main file, in which I consume that job, but I want to modify the logic a little bit. I don't want to hard code that logic in the module. I want to have the ability for it to be flexible enough to accept my logic from a different place. So maybe I can provide a callback, but again, I have only one callback, right? Maybe I can use an array of callbacks, but it looks kind of weird, right? So again, it's not very scalable in developmental sense. So let's use event emitters. And another reason why event emitters are so cool, because they're part of the core platform. We don't need extra libraries. And they used a lot in the core of Node.js. So knowing event emitters is really good. So let's take a look. We require utils just because we want to use that inherits. Remember inherits, right? It basically takes parent and takes the children or child, and then it gives the properties of a parent to a child, right? So we give property of require events.eventEmitter. That's a class from the core library. We give to our class. So job, it's our class, we wrote it. And then what we're doing, we get this magical method, emit. This is coming from the library events. And then all we need to do, we just trigger that event. What is good about this implementation versus callbacks, if we don't listen, this is how you listen in your main program. If you don't listen to that event, nothing will crash. While in a callbacks, if you don't specify the callback and your module is calling the callback, it's expecting it, it will crash, right? It will say reference error. In this case, it's totally fine. It's fault tolerant. We don't have to have this event listener. But if we want to extend the functionality, that's how we do it. We can also get some data. So details will be coming from the module. And then what's cool about it, we can remove event listeners. We can get the list of current event listeners. We can specify that, hey, execute that event just once, even if it's triggered many times, right? So we have much more power than versus traditional callbacks. Obviously, to define the event listener, you need to use callback, but this pattern is great. More about asynchronous ways of managing your asynchronous. There are a lot of libraries, a lot of other patterns, but let's leave it for another talk. Few of the smaller patterns, dependency injection, for example. This is Express middleware that allows you to have a session. So typical web session, but the session middleware, it's agnostic of what storage you use. So by default, it will use the in-memory storage. But the problem with that is every time you restart your server, it will crash, and your users would not be happy because they would lose their logins. We can pass the actual persistent storage, like a database like Redis or Next or something else. Even Postgres can be used, or MongoDB. But the beauty of this pattern is that our session middleware doesn't care what storage you're using. So we can modify, we can just pass on the fly sort of what storage we will use. So that allows for more flexibility. Happy uses a similar thing. So this is how we can configure a different templating engine. Express routes. This is another pattern that we can use to basically, when we require a module, we can pass any data, right? If we require it as a function. So in this case, I'm passing the whole Express app. And then inside of the module, I'm just mounting my routes to that app. So it's kind of in reverse. Instead of mounting my routes in my main server.js or app.js, I'm offloading, I'm outsourcing that job to the module, right? Okay, this is another problem. How do you create a function that is smart enough to give us other functions? So basically, it's like a function factory, but I want to have this custom thing. Function that is smart enough to give me other functions. So how would you define f? This way, when I pass different cities, I get a function, and when I call that function with the different words, it gives me different greetings, right? So this pattern is called function which returns a function. Clunky name, someone called it monad. I start calling it monad, and then I was called by a functional programmer that it's not actually a monad. I don't know if we have functional programmers here. Maybe you can tell me what is the right name for this. Basically, we have a function. The app is kind of saved because the inner scope has access to the inner function has access to the outer scope, and then we can use the app inside for our next function. There are good modules, for example, hooks we didn't talk about, but Mongoose, very popular database module, it uses this library to implement its hooks. Then for the plugin pattern, if you don't want to manually import each file, you can use one of these libraries. So it will import and export the whole directory. OPN, that's a small library that will open the browser from your Node process. And obviously there are more patterns. Good book, highly recommend, by Mario, Node Design Patterns. 30-second summary. Callbacks, don't be afraid of them. They are everywhere in the core, know how to use them. Observers, give you more functionality over callbacks. Singleton, that's when you want to use a shared state. Plugins, that's a nice way to organize your code besides publishing an NPM module. Middleware, that's how you abstract your logic and create continuity. And we talked about a bunch of other stuff. So in the end, that was a lot of patterns, but start with what you need right now. Try and see if it's working. For example, functional versus prototypal or pseudo-prototypal inheritance or ES6 classes. Just try and see if you like it, right? Because there are so many. We had talk yesterday on the burnout, right? So there's so much JavaScript burnout right now. It's better to master in certain things than to be a master of many things. And yeah, don't follow the latest fad, and don't fight with Node and JavaScript. Embrace its nature, embrace its functional approach. Don't try to enforce OOP thinking on it too much. So on a scale from 1 to 10, 10 is the highest. Anyone below 8, this is your chance to ask a question. Okay, no questions. That means everyone is 8 and higher. You can get the code and slides here. I have courses on nodeprogram.com, courses on Node and React. Check it. Take a picture if you need to remember this URL. That's it. Thank you.